Google's recent shift to the Rust programming language is making waves in the world of mobile security. For the first time, memory safety vulnerabilities in Android have dropped below 20% of total vulnerabilities, highlighting a significant improvement in software security. On November 17, 2025, Google revealed that this transition has led to a remarkable reduction in memory safety issues, with the company reporting a 1,000-fold decrease in vulnerability density compared to traditional C and C++ code. This change not only enhances security but also streamlines the development process, with Rust code requiring fewer revisions and resulting in faster software delivery. Next, we'll explore the implications of this shift, including how Rust features are being integrated into other areas of the Android ecosystem and what this means for the future of mobile security. If you found this update helpful, please like, share, and subscribe to InfoSec Now for the latest cybersecurity news. Your support really helps us continue building useful content for cybersecurity professionals. In the timeline of Rust's adoption in Android development, several key milestones highlight the transformative impact of this programming language. Google's initial foray into integrating Rust began in 2019, when the company reported 223 memory safety vulnerabilities in Android, primarily attributed to the use of C and C++. By 2024, this number had dramatically decreased to fewer than 50, showcasing a clear trend toward improved security. On November 17, 2025, Google announced that memory safety vulnerabilities now constitute less than 20% of total vulnerabilities in Android, marking a significant achievement in the platform's security landscape. This milestone underscores not only the effectiveness of Rust in combating memory safety issues but also its role in enhancing development efficiency. Jeff Vander Stoep from Google pointed out that Rust's adoption has led to a 1000x reduction in memory safety vulnerability density compared to traditional C and C++ code. The benefits of Rust extend beyond security. Google reported that Rust code requires approximately 20% fewer revisions than C++, resulting in a 4x lower rollback rate and a reduction in code review time by 25%. This efficiency means that developers can deliver safer code more quickly, aligning security improvements with faster software delivery times. Looking ahead, Google plans to leverage Rust's advantages across the broader Android ecosystem, including kernel and firmware development, as well as in critical first-party applications like nearby presence and message layer security. By incorporating Rust into these areas, Google aims to bolster the overall security framework of Android. However, Google emphasizes that Rust's memory safety features are just one component of a comprehensive security strategy. The company advocates for a defense-in-depth approach, integrating multiple layers of safety mechanisms to mitigate potential vulnerabilities. For instance, a recent memory safety vulnerability discovered in the Krabby AVIF parser, which utilized unsafe Rust code, was effectively mitigated by Scudo, a dynamic memory allocator that addresses heap-related vulnerabilities. As Google continues to transition to Rust, it acknowledges that while C and C++ will still be part of the development landscape, Rust presents a more secure and efficient alternative. The journey of Rust's adoption in Android development illustrates a significant shift toward prioritizing both security and productivity, paving the way for a more resilient mobile ecosystem. As Android continues to embrace Rust, the implications extend beyond mere numbers. The reduction in memory safety vulnerabilities is not just a statistic. It signifies a transformative shift in how software is developed and deployed. Jeff Vander Stoep from Google highlights the efficiency gains, noting that with Rust, the software delivery process has become significantly faster. The fourfold decrease in rollback rates and the 25% reduction in code review times suggest that developers can focus more on innovation rather than rectifying past mistakes. Moreover, the transition to Rust indicates a broader strategy for enhancing the Android ecosystem. By planning to integrate Rust security benefits into critical components like the kernel and first-party applications, Google is laying the groundwork for a more robust and secure platform. This move could set a new standard for mobile security, as other companies may follow suit, potentially reshaping industry practices. However, it's important to note that while Rust's built-in memory safety features are a leap forward, they are part of a larger, layered defense strategy. Google's emphasis on a defense-in-depth approach underscores the importance of combining various safety mechanisms. For instance, the recent near-miss vulnerability discovered in an AVIF parser illustrates that even with Rust, vigilance remains crucial. The integration of tools like Scudo, which enhances memory allocation safety, complements Rust's advantages by addressing potential weaknesses that could still arise. In summary, the adoption of Rust in Android development is not merely about reducing vulnerabilities, it reflects a holistic approach to software security and efficiency. By prioritizing both safety and productivity, Google is setting a precedent that could redefine the parameters of secure coding in the mobile landscape. As these changes take root, the industry will likely witness a shift in how developers approach security, ultimately benefiting users with safer and more reliable applications. As Google looks ahead, the integration of Rust into the Android ecosystem is set to expand significantly, promising not only enhanced security but also improved development efficiency. The company plans to extend Rust's advantages beyond its current applications, targeting critical areas such as the Android kernel, firmware, and essential first-party applications like nearby presence and message layer security. This strategic move aims to leverage Rust's memory safety features to fortify the entire Android infrastructure. Moreover, Google has noted a substantial improvement in the development process itself. With Rust's adoption resulting in a fourfold decrease in rollback rates and a 25% reduction in code review time, the company is poised to streamline its software delivery pipeline. This means that developers can focus more on innovation rather than rectifying vulnerabilities, leading to a more agile development cycle. In addition, Google emphasizes a comprehensive approach to security, integrating Rust's capabilities with existing safety mechanisms. While Rust is making strides in memory safety, the company acknowledges the importance of maintaining traditional languages like C and C++, alongside robust hardware safety measures. This layered defense strategy is crucial in addressing potential vulnerabilities, as illustrated by the recent discovery of a near-miss vulnerability in an AVIF parser. The ongoing evolution of Rust within Android not only enhances security but also positions the platform as a leader in adopting modern programming paradigms. By continuing to refine and expand Rust's role, Google is setting a precedent for future software development practices, where safety and efficiency go hand in hand. If you found this update helpful, please like, share, and subscribe to InfoSec Now for the latest cybersecurity news. Your support really helps us continue building useful content for cybersecurity professionals.